Hello there. I'm going to introduce you today to a new topic of complex numbers. And complex numbers are probably shrouded in more mystery than most things in mathematics. They are, just their name. They're also called imaginary numbers. That's why you've got this, on this slide here, you've got this, what is described as a real part and an imaginary part. And traditionally, we've always used the letter I to represent part of this complex number. And the mere fact I'm introducing this weird and wonderful thing called I tells you it's a bit new, it's a bit different. So I want to talk to you today about these complex numbers and how we can get our head around what they represent. First of all, we've got some quadratic equations I want you to use. I've suggested you use the formula to do this. I know you probably think you don't need to, but try to use the formula. So I'll do the first one. So you're meant to say that A equals 1, B equals -7, and C equals 12. And on that basis, X equals minus B. What's that? Minus and -7, so that's +7, plus or minus the square root of B squared. That's 49 when I square -7. Minus 4 times A times 12, all divided by 2A, which is 2. So by my reckoning it's 7 plus or minus, now I've got to do the square root of this. 4 times 1 times 12 is 48. So 49 minus 48 is 1, which when I square root it, and that's the important thing, I've got to square root it. Don't forget to do that. It's 1 divided by 2. So it's either 7 plus 1, 8 divided by 2, which is 4, or it's 7 minus 1, which is 6 divided by 2, which is 3. I should warn you I've done the easy one. So you do the other two and I'll ask you to pause the video and then come back to me. So hopefully you've done those. These are my answers when I did it. I got 3 and 4. Well, that's lucky because that's the answer that I got. 3 and 4. I also got 2 plus or minus root 2. So that's not so pretty. But that's just because you can't square root 2 very nicely. But other than that, you could work out it's 2 plus root 2. Which is about 3.14 or something like that, or 3.41, sorry. And you could do 2 minus it, which presumably is about 0.59. But other than that, decimals or in surd form is fine. But this is the little weird one. I suppose I should show you my logic on this one because it's certainly weird. You should have done it. What we've got, A is 1, B is -4. And C is 10. So if I chuck these numbers in, I get X equals minus B. Again, is again negative, so I can ignore that. It's 4 plus or minus the square root of B squared, which is 16, minus 4 times 1 times 10. So what have I got there? All divided, by the way, by 2A, which is 2 again. So we've got, when we do this, 4, obviously, plus or minus. Now it's 16 minus 40. Now this is the problem. 16 minus 40 is minus 24. Minus 24, you try to do that on your calculator, it will cry. It will say, no, I can't do it. If you ignore the fact that it says a minus, it's the square root of 24, I suppose. And if you were doing the square root of 24, you might conclude it's the square root of 4. Times the square root of 6, and that could be written as 2 root 6. So here's the thing, whenever I get a minus root, I just pretend it's not, and I'm going to write 2 root 6. But because I pretended it's a square root of this negative thing, I put an I, because I've imagined some weird answer. All divided by 2, and then my final answer is 2 into 4 goes 2, plus or minus 2 divided by 2 disappears, so that can go and root 6i. So that's where the answer comes from, but I think you probably agree it's not very nice and it's a bit weird. This I we can think of as the square root then of a -1. This effectively is our definition of I. In the past it was always defined or said to be undefined. We were always told we couldn't square root a negative number, but people eventually played around with it a bit like I did, and you end up getting answers which later on, sometimes in real life problems, come back to then get rid of this weird answer, and suddenly you've got a real answer again, and it's suddenly you think, well, it was worth doing. So if we square root -1, sometimes we get this interesting maths, which, as I've said, this is what I want you to make sure you know about. Write it down. The square root of -1 is I. And so I have got these things going on here. So based on that the square root of -1 is I, it's reasonable to say, let's just rewrite what I just said, the square root of -1 is I. Now, I suppose technically it's plus or minus I. Now, I'm going to say ignore the fact it could be either. Just think of it as just the plus version. It makes it a lot easier. Now, the square root of -4 then, it's not unreasonable to say, well, that's 2i, because if I square root 4, I get 2, and if I square root minus, I get an I. If I square root 9, I get 3, but if it's minus, I get an I. So, in many ways, this becomes relatively easy. The square root of -25 is just now 5i. Now, bear this in mind, because we also know a few things about this. Now, I squared, I'm going to say, is but obviously I times I. And I know that I is the square root of -1. Therefore, it's got to be times by the square root of -1. And whenever you square something, which is effectively what I'm doing, I'm undoing. So -1 times -1 is now 1. Can you see? What I'm trying to get at, I suppose, is the square root of -1. If I square it, that kind of cancels each other out. And so it's not unreasonable to say, well, that's therefore -1. So I squared, we're going to make sure we know, is -1. And I cubed is interesting as well. I cubed is obviously I times I times I. But I know what I times I is. I times I is, as I've just said up there, -1. So if I times it by I again, my answer is -I. Because that times that is -1, times by I is -I. And I to the 4 is interesting as well. Obviously I know that I times I, I've already worked out, is -1. And that times that is -1. So it's not a great shock to hear that -1 times -1 is 1. I to the 4 is 1. So you end up with this list of I equals I, obviously, then I squared equals -1, I cubed is -I, and I to the 4 is 1. And it begs the question, what comes after that? Well, you'll soon realise that I to the 5 is I to the 4 times I again, which is 1 times I, which is I. And I to the 6 is I squared, effectively, which is -1. And I to the 7 is like I cubed, which is -I. And I to the 8 is, well, it's back to 1 again. You're just repeating these 4s, this loop of 4. And it's quite useful, that information. I will say then that from now on, all complex numbers, they will have an I in them, but there's potential for it to have an extra part. And we saw that in the very first answer that we had. I can't remember what it was now. But we ended up with an answer which was 2. I think it was 2 plus root 6i. I think it might have been 2 plus or minus root 6i. Notice then we had this real part, and we had the imaginary part, the root 6 part. And these are the common forms of complex numbers. And you usually put a z in front of them. Z, because it's, I suppose it's x, y, z. It's the, but it's the, you don't usually write, normal numbers with z's. And yet here we have something which is very, very obviously not normal. So therefore they've used z, and z is the common number to use, and often w, believe it or not, because I suppose it's close to x and y again, but it's not normally used. So both a and b are real numbers. That's the definition of this. You can't have a complex number within a complex number. So typically you might get 2 plus 3i, or 1 minus 1 plus 5i. These are both complex numbers, and we define a complex number then to be a real part and an imaginary part. So what happens if you try to add them, or take them away, or times them, I suppose? Well, 3 plus 2i is what I'm saying p is. I've just made these up. Q, I've said, is this, and r is this. So having made those up, what does p plus q equal? Well, it's not rocket science to go, well, 3 plus 2i minus 1 plus 3. Well, just add them together. So 3 minus 1 is 2. And 2i plus 3i, that's 5i. There you go. That was easy enough. This one's a little bit harder because I've got to double the q first. So let's write this out. 2 lots of minus 1 plus 3i. And it says minus r. What was r? Minus the 4 minus I. So you just got to be a bit careful. So minus 2 plus 6i minus 4 plus I squared. I squared. Remember what I squared was? I squared was minus 1. So you've got to be careful of things like that. So this is going to give me minus 2, minus 4, that's minus 6. And another minus 1 because of this, that's minus 7 plus 6i. That's a bit of a surprise, I suppose. You know, a lot of people wouldn't have spotted that. I squared is minus 1. Now what's p squared? Well, it's obviously 3 plus 2i times by 3 plus 2i. Now this is double brackets effectively, so I multiply it out. 3 3s are 9, 3 2i's are 6i. 2i lots of 3 is another 6i. It's getting easy, apart from what's the sting of the tail. 2i times 2i is 4i squared. And we've said that I squared is minus 1. So we've got to bear that in mind. This really is minus 4. So I've got 9 and a minus 4 is 5 plus 12i. And again, watch out for the I squareds at the end there. RQ, what's R? 4 minus I times by Q minus 1 plus 3i. Multiply them out. Minus 4 plus 12i plus another I minus 3i squared. Oh, be careful again. I squared is minus 1. Now, it's minus 3 times that minus 1, so that's like a plus 3. So we get minus 4 plus 3, that's minus 1. I reckon plus 13i. Well, I think a relatively nice one to finish with. It says q plus r, so q is minus 1 plus 3i plus r, what was r? 4 minus I. Minus p, well, just be a little bit careful, it's minus 3 plus 2i. So you've obviously got to take into account the bracket. So we've got minus 1, so this makes this minus 3 minus 2i, I think. Minus 1 plus 4 is 3, minus that 3 is 0. Alright, we've got 0. 3i minus I is 2i. Oh, right, it is 0 plus 0i. Well, I reckon it's probably best just to write that as 0. And there's my answer. It's interesting I did write that as a 0. And that's it. Our job is to practice these and then go on to the harder operations. And you notice we haven't looked at division yet, for instance. So we're going to look at harder operations in due course. Have a look at those.